So, let's go. Number 1, the warped disk. You know the picture. The Milky Way as a flat, tidy pinwheel spinning in one clean plane, everything neat. That picture is wrong. It was always wrong. The disk of your galaxy is bent, not a little. One side of it curls up out of the plane, the other side curls down, like someone took a vinyl record and left it on a hot dashboard. Astronomers call it the warp, which is a very calm word for the shape of your entire home is crooked, and nobody agreed to it. And here's the part that should get under your skin. It moves. The warp doesn't sit still. It wobbles around the center of the galaxy like the last slow turn of a spinning top before it falls, and one full wobble takes somewhere between 600 and 700 million years. There's a wave rippling through the disk, too. A corrugation, like the surface of a pond that got hit by something and never fully calmed down. We didn't guess this. A spacecraft called Gaia sat out in the dark and measured the exact position and motion of nearly 12 million stars, one by one, and when you plot where they actually are instead of where the textbook says they should be, the flat galaxy melts away and this crooked, rippling sheet takes its place. You are standing on the ripple. You always have been. Now feel the real problem. We can see that the galaxy is bent. We cannot agree on what bent it. One idea says a smaller galaxy is crashing through us right now, sending waves out like a rock dropped in water. Another says it's the ghost of a galaxy we swallowed billions of years ago, still ringing us like a struck bell. Another blames the gravity of a companion galaxy tugging on our edge. Pick one. A collision happening as you breathe. A death that happened before the sun existed. A neighbor pulling on us from across the void. Each answer is a different flavor of your galaxy was shoved hard and it never stopped shaking. You will never feel it. From inside the warp, the sky looks flat. Because your eyes are riding the bend along with everything else. The band of light you call the Milky Way looks straight only because you are trapped inside the curve. The most reproduced image in astronomy, the flat spiral, is a lie of perspective. And that's the easy one on this list. Number 2, the local bubble. Look up on a clear night and space seems full. Full of stars, full of stuff, packed. It isn't. You are sitting in a hole. There's a cavity around the sun about 1,000 light years wide, and it is close to empty. Thin, hollowed out, scooped clean. Astronomers call it the local bubble, and for a long time it was just a curiosity. Then, in 2022, they figured out how it got here, and the answer is not comforting. It was blown open by dying stars. Starting around 14 million years ago, a run of supernovae went off, one after another, and each explosion shoved the gas outward, carving this enormous cavity into the galaxy like a blowtorch through a snowbank. You live inside a blast crater. A very old, very large blast crater, but a crater. Here's the detail that turns it from trivia into something stranger. Every single young star, every star-forming cloud within about 500 light years of you, sits on the surface of that bubble, not scattered randomly through space. Stuck to the wall like frost forming on the inside of a balloon. The explosions that dug the hole also raked the gas into a shell, and that shell is where new stars are being born right now. Which means the famous nurseries, the ones in Taurus, in Orion's neighborhood, the pretty pink clouds in every space documentary, aren't just floating out there by chance. They're beads on the rim of a wound. Now when you look toward them, you are looking at the edge of the pit you live in. And you're not even supposed to be here. The sun only wandered into this bubble about 5 million years ago, drifting through on its long lap around the galaxy. The fact that you're near the middle of the cavity right now, rather than off in a wall somewhere, is a coincidence. Give it a few million years and we drift out the other side. So the clean, empty, peaceful patch of galaxy you were born into is the aftermath of a chain of explosions. The walls are made of the shrapnel. The shrapnel is busy building new stars, and your home star is just passing through. A tourist that showed up long after the violence was over. You didn't get a quiet neighborhood, you got the calm inside the crater, and even that is temporary. Number 3, the Radcliffe Wave. Right next to you, in galactic terms, there's a structure so big your brain refuses to hold it. A chain of gas clouds and newborn stars stretched out in a line about 9,000 light years long. 9,000 years for light itself to run from one end to the other. And it is shaped like a wave. They named it the Radcliffe wave, and for a while everyone assumed the name just described the shape. A frozen ripple in the gas. A pretty coincidence. Then, in 2024, someone checked whether it was actually moving. It is. The whole thing is oscillating, not sitting there looking wavy. Physically waving, rolling up and down through the plane of the galaxy, the massive star-forming clouds rising and falling, like a stadium crowd doing the wave in slow, enormous, silent motion. The star nurseries at the crests are climbing, the ones in the troughs are sinking, and the entire structure is also sliding outward, away from the center of the galaxy, drifting as it waves. Sit with the scale of that. This is not a small thing wobbling. This is the backbone of the nearest spiral arm, the literal skeleton of the region you live in. And it is flexing like something alive. If this arm is doing it, the researchers pointed out, maybe every spiral arm in every galaxy is doing it, and the calm, fixed pinwheels in every poster are actually rippling sheets caught in a single frozen frame. And of course, because this is the galaxy, we don't know why. Something set this wave in motion. A dwarf galaxy that punched through and left the gas ringing. A clump of dark matter passing by. Something. There's even an argument that the wave shouldn't last long, that the churning of the galaxy should tear it apart fairly quickly, which means we may be looking at a temporary thing, a wave already in the middle of breaking, and we just happen to arrive in time to watch. You will never see it move. It rolls on a timescale that makes a human life look like a camera flash. But it is moving right now. A 9,000 light-year serpent of gas breathing in and out beside your home. And until 2 years ago, nobody even knew it had a pulse. The neighborhood isn't just crooked, it's swaying. Number 4. The Eaton Galaxy. Here is where the story turns, so slow down for this one. Everything so far has been the galaxy being oddly shaped, oddly restless. This is the galaxy being a killer. Because a huge fraction of the halo around you, the great cloud of old stars wrapped around the disk, is not originally ours. It's the corpse of another galaxy. We ate it. About 10 billion years ago, back when the Milky Way was young and small, another galaxy came in too close and lost. Our galaxy pulled it apart and swallowed it whole, and the victim stars are still here, still circling us, wearing their history in the way they move, because they don't move like locals. Ordinary Milky Way stars ride around the center in smooth circles. These stars fall in and out, plunging toward the center and back out again on long, violent radial orbits, like the whole population is still reeling from the impact that killed their home. There are around 30,000 of them that gave the secret away. Gaia watched them, saw them all moving wrong in the same way, and astronomers realized they were staring at the shredded remains of a devoured galaxy threaded right through our own. They gave the dead galaxy a name. It doesn't need one. It needs a headstone. And it was not a snack. When it hit, the victim was something like a quarter of the mass of the young Milky Way. This wasn't a big fish eating a minnow. This was a fight. And we won by absorbing the loser so completely that its stars now orbit inside us, indistinguishable to the eye, betrayed only by the fact that they never learned to move in a circle. Now look at everything on this list again, because the frame just changed. The warp that won't sit still. The stars that move the wrong way. The clumps of something invisible tearing through streams of stars. A galaxy that grew by eating other galaxies is not going to be tidy. It's going to be a stitched-together thing. Full of scars, full of leftovers, still digesting. And it may not have happened only once. Newer work hints. There was an even older meal before this one, and that some of the most ancient stars around you predate the galaxy we usually blame for everything. You don't live in a pinwheel, you live in a graveyard that kept moving. Number 5, the wrong way stars. Once you know the galaxy is a cannibal, you start looking at the other stars differently. You start asking which ones belong here. And a few years ago, a machine started asking the same question and it found something nobody was looking for. Researchers turned a deep learning program loose on the Gaia data, millions of stars, and told it, essentially, find the ones that don't fit. And it flagged a group, around 500 stars moving together in a herd that are doing something the rest of the galaxy doesn't do. They lag behind the spin. While the disk streams around the center one way at full speed, this pack is dragging, orbiting on stretched eccentric paths out of step with the current around them. They named the stream Nyx after the goddess of night. Fitting, because nobody can see what it really is. The first read was thrilling and grim at the same time. Another swallowed dwarf galaxy, another meal, its stars still moving in the pattern of the impact that brought them in. Discovered not by a person, but by an algorithm noticing a smudge in the data that human eyes had slid right past. A ghost pulled out of the numbers. But here's the twist, and it's the honest one. The more people looked, the less sure they got. Maybe Nyx isn't an invader at all. Maybe it's just part of our own thick disk. A local crowd that happens to move a little strangely, dressed up as a mystery. The argument is still going. The stars are real, the motion is real, and the identity is a genuine open question. Which is, weirdly, the most unsettling outcome. Because think about what that means. We can point a spacecraft at the sky, measure 1,000 stars to absurd precision, feed them into a machine smart enough to spot a pattern we missed, and still not be able to answer the simplest question you could ask about them. Are you from here, or are you the leftovers of something we killed? We don't know. The herd keeps moving against the grain, silent, sorted out by a computer, sitting in a folder labeled maybe. And that's the galaxy for you. It doesn't just keep secrets, it keeps secrets we can find and still not read. Number 6. The hidden black hole. Black holes come in two sizes everyone knows. Small ones, a few times the mass of the sun, left behind when a star dies. And monsters, millions or billions of suns, sitting in the hearts of galaxies. The one at the center of the Milky Way is one of those monsters. For decades there was a hole in the middle of that story, the in-between kind. Thousands of suns, not millions. The teenagers of the black hole world. Every theory said they should exist, as the seeds the monsters grew from, and yet almost nobody could find one. A whole missing class. Then, in 2024, they caught one. And it was hiding close. There's a dense ball of stars called Omega Centauri, a globular cluster, about 10 million stars packed into a glittering knot. Astronomers pulled more than 500 Hubble images of its core, spanning 20 years, and tracked 7 stars near the center that were moving too fast. Way too fast. Something was whipping them around. Something you can't see. And when they did the math, the only thing that fit was a black hole of at least 8,200 times the mass of the sun. The missing middle child, finally caught in the act. And here's the part that should make the back of your neck prickle. It's near us. The monster at the center of our galaxy sits about 26,000 light years away. This one, the newly found one, is only about 17,700 light years off. Closer. A black hole of a kind we'd basically failed to find for decades, and it turns out one was sitting in our own backyard the whole time, betrayed only by 7 stars running for their lives. Which raises the obvious awful question. If this one hid in a star cluster right next door, unnoticed until someone stacked 20 years of pictures and squinted, how many more are out there? Some estimates say that single cluster could be hiding thousands of black holes, and this was just the first one big enough to catch. Thousands of dark, silent, invisible mouths in one glittering ball of stars, and we found exactly one. You were told we understood black holes. We can't even count the ones in our own neighborhood. Number 7. The missing stars. Out in the halo of the galaxy, there's a stream of stars called GD1. Picture a thin river, a long, delicate string of stars strung out in a line, pulled from a star cluster that got stretched like taffy as it orbited. Neat, clean, thin. Exactly the kind of thing that should be uniform all the way down. Except it isn't. There's a gap in it, a chunk of the river just missing, a clean bite taken out of the stream, and beside the gap there's a spur, a little group of stars kicked off to the side of the line. Something hit this river. Something plowed straight through it, scattered the stars, and left a hole and a splash. So astronomers did the natural thing. They asked what could do that. And they ran the numbers on the object that must have passed through. And the numbers came back wrong in the most interesting possible way. Whatever hit GD1 was heavy, somewhere between 100,000 and 100 million suns. It was compact, small, and dense for that mass. It passed close, within the last chapter of the galaxy's life. And it left no light. There is no star cluster on that orbit, No visible object where the puncher should be. You've got a smoking gun, a fresh wound, a trajectory, and an empty seat where the shooter should be sitting. The leading suspect is a clump of dark matter, an invisible knot of the stuff that makes up most of the galaxy's mass and has never once been seen directly, barreling through a stream of stars and leaving a dent as its calling card. If that's what happened, this gap is about the closest thing we have to a photograph of dark matter actually doing something, not inferred from a spinning galaxy, caught mid-swing. But even that answer misbehaves. Because when you check the object's density against what our best theory of dark matter predicts, it comes out too dense. Denser than the theory allows, by enough that people are now inventing new kinds of dark matter to explain one hole in one stream of stars. So here's where you're left. A river with a bite taken out of it, an invisible thing that did it, and a wound that fits none of our theories cleanly. The galaxy took a shot at a line of stars. The bullet was made of the dark stuff that outweighs everything you can see, and we can't even tell you what the bullet was made of. Number 8, the Smith Cloud. In 1963, a student mapping hydrogen gas noticed a blob, just a smudge of gas out past the disk of the galaxy. It got her name, the Smith Cloud. And for a while it was a footnote, then people worked out what it's doing, and the footnote grew teeth. Because the Smith Cloud is not drifting away. It's coming back. It is a clump of hydrogen more than 10,000 light-years across, around 2 million times the mass of the Sun. And it is falling toward the disk of the Milky Way at something like 73 kilometers every second, a cloud the size of a small galaxy on a collision course inbound. Impact is in about 27 million years. It's going to slam into the disk at a steep angle, out in one of the spiral arms, and when it hits, it isn't going to end anything. It's going to start things. The impact is expected to compress the gas and trigger a burst of new stars, a whole nursery lit up by the crash. A cloud falls out of the dark and a generation of stars gets born from the wreck. Here's the eerie part. This isn't its first pass. Trace the cloud's path backward and it looks like it already punched through the galaxy once, roughly 70 million years ago, back when dinosaurs were still walking around down here. And it survived. A loose cloud of gas should have been shredded and smeared out by a trip through the disk. This one held together and came back around for another lap. The best explanation for how it survived is the same ghost that keeps showing up on this list. Dark matter. The cloud may be wrapped in an invisible halo of the stuff, a dark shell holding the gas together like a fist around a handful of smoke, letting it dive through the galaxy and come out the other side intact, reloaded, aimed. So while you go about your day, there is a thing the size of a small galaxy, wrapped in something we can't see, that has already hit us once, arcing back around for a second strike that's fully scheduled. It's not a threat to you. The timescale is longer than our entire species has existed, but it is out there. It is inbound. And the galaxy has, in the most literal sense, a round already in the air. Number 9. The signal from inside. There's a kind of signal astronomers have been chasing across the universe for years. Fast radio bursts. Blinks of radio energy so bright and so brief they last 1,000th of a second and outshine whole galaxies, arriving from billions of light years away, from sources nobody could pin down. Genuinely, one of the great mysteries. Something out there screaming in a language we couldn't place. And then, on April 28, 2020, one of them went off inside our own galaxy. The source was a magnetar. A magnetar is what you get when a dead star's corpse decides to become the strongest magnet in existence, a city-sized ball of neutron matter wound so tight its magnetic field would scramble your body's chemistry from 1,000 kilometers away. This one, sitting about 30,000 light-years from you, right here in the Milky Way, suddenly fired off a burst of radio energy exactly like the ones we'd been hunting across the cosmos, along with a flash of X-rays. It was the first fast radio burst ever caught coming from inside our own galaxy. The first one where we could turn around, point at the source, and say, that's what did it. Years of mystery from the far side of the universe, and the answer coughed once, close to home, where we could finally get a good look. You'd think that would settle it. Case closed, it's magnetars. And it did prove that at least some of these cosmic screams come from these dead, over-magnetized stars. But the mechanism, the actual how, the way a star's corpse can throw out a flash bright enough to cross the observable universe in a millisecond, is still argued about. We caught the culprit in our own house and still can't fully explain the crime. Which is the quietly disturbing takeaway. You tend to think of the truly exotic stuff, the reality-breaking physics, as a faraway thing. Out there. Safely distant. And then the most extreme kind of radio flash in the known universe goes off in your own galaxy, from a dead star you didn't know could do that, and you realize the strange isn't out there at all. It's in the room with you. It just doesn't go off very often. Number 10, the zone of avoidance. Here's a thing nobody tells you about living inside a galaxy. It blinds you. There's a region of the sky astronomers call the zone of avoidance, and it's exactly what it sounds like. A band across the sky you cannot see past. It's the direction you look when you look into the thick of the Milky Way itself, straight into the crowded, dusty disk, and all that gas and dust and jammed-together starlight throws up a wall. About a quarter of the entire sky beyond our galaxy is hidden behind it. A full 25% of the universe blocked, because our own home is in the way. And it's not empty back there. That's the maddening part. Whole galaxies are hiding in the zone of avoidance. Entire clusters. There are enormous structures back there. Superclusters, some of the biggest things in the universe, that we only found by peering through the gaps or switching to wavelengths that slip through the dust. For decades, cosmologists trying to map the universe had a quarter of it smeared out by a curtain of our own stars. Think about what that does to everything else we say. Astronomers talk with total confidence about the large-scale shape of the cosmos, the way galaxies clump into a great web, the way everything flows. And a quarter of the map has a coffee stain over it, and the stain is us. We are standing inside the one object that we most want to see past. There are tricks. Radio waves from cold hydrogen cut through the dust so we can catch galaxies back there by their hydrogen glow when we can't catch them by their light. Bit by bit, the curtain gets thinner. But it never fully lifts. There's a permanent blind spot wrapped around your sky, and it is made of the exact same galaxy you're using as a home. So every picture of the universe you have ever seen, every map of the cosmic web, has a wedge cut out of it. Not because the universe is empty there, because we were born inside the thing doing the blocking, looking out through a windshield that's caked in our own stars, quietly certain we can see the whole road. We can't. We never could. And most of us never even knew the wall was there. Number 11, the brick. Stars are supposed to be simple to make. Take a big cloud of cold, dense gas, let gravity squeeze it, and it collapses into stars. More gas, more density, more stars. That's the rule. It works everywhere. Except in one place near the center of our galaxy, where a cloud is sitting there, dense and cold and enormous, flatly refusing to obey. They call it the brick. It's a cloud of gas so thick and dark it blots out the crowded starlight behind it, a black slab against the blaze of the galactic center. It has more than 100,000 suns worth of material in it. It is far denser than the clouds that normally erupt into new stars. By every rule we have, it should be one of the brightest star factories in the galaxy, cranking out new suns. It's making almost nothing. It's nearly sterile. It breaks the standard laws of star formation by something like a factor of 45, which is a polite way of saying it's not a little off, it's a scandal. A cloud with everything it needs to build stars, sitting in the dark, building nothing. And when the James Webb Telescope looked closely, in 2023, it didn't clear things up. It got weirder. Webb found frozen carbon monoxide, ice, spread through the cloud far more widely than anyone expected, a hidden layer of frost woven through the dark. There's even a suggestion that something violent is buried in there, a hidden supernova remnant carving a bubble inside the cloud from the inside out. Nobody has nailed down why the brick won't make stars. Too much turbulence, too strong a magnetic grip, too young to have started. Take your pick. It's a fight with no winner. Here's why that matters more than it sounds. Making stars is the one thing galaxies are for. It's the most basic job the Milky Way does, the process that built the sun, built the atoms in your hands, built you. And here, near the heart of your own galaxy, sits a cloud doing that job wrong. In a way we cannot explain, using rules we thought we understood cold. We can model the death of the entire universe. We can't tell you why one dark cloud in our own galaxy is sitting on its hands. Number 12. The weight of everything. So here's the one that ties it all together, the concern under every other concern on this list. After everything, after the warp and the wave and the eaten galaxy and the invisible bullets, there's a simpler question you'd think we'd have nailed by now. How heavy is the Milky Way? We don't know, not roughly. The honest answer is that the best estimates of the total mass of our own galaxy disagree with each other by something close to a factor of 2. Double. As in, the galaxy might weigh a certain amount, or it might weigh twice that, and depending on which method you trust, you get a different answer, and nobody can force them to agree. The reason is the same shadow that's haunted this whole list. Most of the galaxy isn't the part you can see. The stars, the glowing gas, the bright spiral, all of that is a minority. The bulk of the Milky Way is dark matter, an invisible halo spread out far past the edge of the light. And out there in the dark, there's almost nothing left to measure it by. The visible stuff runs out, the gas runs out, and the few lonely clusters and dwarf galaxies drifting in the far dark are all we've got to weigh the whole thing with. It's like trying to weigh a person by studying the lint on their sleeve. We can't even agree on how many stars are in it. You'll hear 100 billion. You'll hear 400 billion. That's not a rounding error. That's us not knowing the number of stars in our own house to within a factor of a few. We can't draw a clean line and say, there, that's the edge. The galaxy stops here. It just fades out into the dark and the dark keeps going. Now step back and look at the whole list. We've measured the position of the edge of the observable universe. We've mapped light from the beginning of time. We can tell you what happened a fraction of a second after everything began. And we cannot tell you, within a factor of 2, how much the thing you are standing inside actually weighs, or where it ends, or how many stars it holds. We know the far shore of the universe better than we know the floor under our feet. And the more carefully we look at our own galaxy, the less finished it seems. The more it looks like a crooked, swaying, half-digested, unweighable thing that we happen to live in the middle of, quietly telling ourselves we understand it.